So now that the script has been recorded, we can play it back at any speed we'd like. We record bitmap files and then play those back because they give us the greatest flexibility. No matter how complex our scene, we'll always be able to have real-time playback.
Three simple states combine to create a complex organic motion, and the artist can work independently on each part of the motion, making adjustments to the animation easy. But the real power of Symbolics is that it lets you create animation scripts for simple objects, then reuse those scripts on more complex versions of the objects. To illustrate this, we make a smooth version of our plane and then run this complex object through the same animation we've just created.
Now we'll see the complex version of the plane going through its movements based on what the simple one did, but there's a lot more subtlety to the movement in this one because it's got a finer polygonal mesh on it. Okay, so now that that's finished, let's take and play it in a loop.
The Symbolics animation design process fits the human model. It allows the artist to start with rough sketches and move to smooth, finished animation, making interactive adjustments to both motion and models along the way. Here is another example of working from rough to smooth.
This is a version of a head talking. So here's the mouth talking. But we see it's a very simple polygonal mesh. It would be obvious, no matter how smooth the motion, it would be obvious that a computer generated this, and we'd like to avoid that. So let's go to a higher polygonal mesh, meaning let's look at the smoothed object here.
The key notion in displacement animation is that several displacements can be simultaneously combined or overlaid to create a single complex motion.
So let's take a look at exactly what they're doing as they overlay. Here we'll scroll this with the mouse, and on the top line we can see the mouth open and close and open and close and open and close. On the second line here we can see the corners back, forward, back, forward, back. On the third line we can see ooh, ooh, ooh. And on the fourth line, we can see a smile, off, smile, off.
From these four simple displacement states, we get some very complex motion because of the ability of the displacements to overlay one another. Next, Matt animated the individual letters of a Sony logo to demonstrate the power of the interactive sketch editor.
The sketch editor allows you to actually sketch your curves in time instead of having to define them procedurally or define them in terms of points of knots across a line or something like that. You can just go in and physically draw them out and modify them by drawing on them. And we'll put a little curve up here. And now if my drawing is particularly bad or something, I can run over it with a low-pass filter and smooth it out. I could maybe copy it somewhere else and then invert it for something to happen in conjunction with this. Or I can set different curve types on it. Here I'll set a linear curve. Again, I can draw on this at any moment in time and then smooth it out. We can set a slow in or a slow out or a slow in, slow out. We could do a bounce curve. So let's give this, say, 5 bounces. And so here we see a bounce, a bounce, a bounce, 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 bounce. So it's both becoming faster in frequency and less in power with each bounce. Here we could do a sine wave. Run a sine wave through something. We'll put 5 sines through that. Or we can do a dampened sine wave. In this case, let's just put 3 in. And we see them dampening out. This is exactly the kind of curve that we used for the swinging of the O at the beginning. So let's go back and take a look at that again. And if we zoom in on it, this has actually two signs through it. And if we scroll through this, we see the O starts, it moves, rocks the other direction, and then dampens out and stops in the middle. So now let's take a look at that playback in color.
The sketch editor allowed for rapid scripting of this logo animation. Matt's next example illustrates the benefits of Symbolics' unified 2D and 3D capabilities. We'll see the high-end look of the 3D Nike logo combined with the speed and efficiency of a 2D background.
Now that we have that as a 3D object, we can animate it in a number of different ways. And back up in our black and white here, I'll play this in a forward loop. I did a fly-on of this Nike and then landed it. And instead of having to figure out how much to move it in Z and X and Y and rotations and all this kind of stuff, what I did was I built a trajectory. And what's a trajectory? A trajectory is just a line in space that I inscribed and just said, start here, go here, go here, go here. And it just followed all along that path and automatically banked itself through the corners and that kind of stuff. And then there have been some displacements added to make it wiggle like Jello when it hits the end. Okay. The next thing we want to do with this is once we've seen this animation, we want to make a test render before we commit to rendering the entire thing out.
In preparation for this demo, Matt had performed a reduced resolution full-color test render of the animated Nike logo. The frames were stored in the Symbolics machine and can be played back in real time through the frame buffer.
So it's small, so it's rather pixelated, but it does give us a very complete idea of what's going on.
Test render completed, Matt then presented a fully rendered Nike animation sequence which had been recorded on an Abacus A62 digital disc recorder.
So this is a combination of two-dimensional and three-dimensional animation.
Tight integration of 2D and 3D production environments allows for speedy production of complete animated sequences.
So the Nike will pass behind these rocks and then land in front of it. So here if we play this, we'll just play it forward, we'll play it full speed, and we have it flying out behind and landing in front of the rocks. There's also, if you notice, the color changes from the darker to its full gold. That's a recolor operation. It's just recoloring it so that it has some appearance of being in the shade behind those spires of rock.
From cost-effective flying logos to the frontiers of high-end character animation, the Symbolics unified graphics environment delivers flexibility and power. Matt's 1990 award-winning HD TV animation, The Little Death, introduced synthetic star the leopard-skinned Lotta Desire. Today, Matt presents Lotta with a new, more human skin. Her new smile made possible by Symbolics' advanced mapping tools. Symbolics mappers help place 2D texture maps like this onto 3D models like this. The power of Symbolics' unified graphics systems is this: state-of-the-art 3D tools combined with powerful 2D capabilities, which allow the Symbolics artist to tackle any job with a single integrated system.